There are two separate equipment cooling systems, one forward and one aft. The forward system cools the avionics equipment in the forward E&E compartment and the cockpit instruments. The aft system cools the equipment in the aft E&E compartment. In the forward cooling system, air from the passenger cabin is circulated by one of two supply fans. After the equipment is cooled, exhaust air is drawn through the left air conditioning recirc fan and then returned to the air conditioning system. Conditioned air for the aft cooling system is drawn from the aft passenger cabin by one of two supply fans. Exhaust air from the aft cooling system is ducted into the lavatory and galley vent system. The equipment cooling controls and indicators are located on the overhead panel. Both systems are controlled by the alternate equipment cooling switch. During normal operation, the switch remains in the normal unlatched position, as indicated with the legend extinguished. This allows one supply fan from each cooling system to operate. Now let's look at abnormal operations. If a supply fan fails, it automatically switches to the second supply fan. The equipment cooling overheat light illuminates if a supply fan switching failure occurs in either the forward or aft systems. In addition, the associated ICAS message will appear. The alternate fan can be manually activated with the alternate equipment cooling switch. This reestablishes airflow, which should cause the overheat light to extinguish. In this example, the aft equipment cooling supply fan has failed, and the automatic switching did not occur. Now click on the appropriate switch to manually activate the alternate equipment cooling fan. If the overheat light does not extinguish, flight beyond 90 minutes can result in the loss of essential avionics and electronic equipment. An equipment cooling smoke light will illuminate if smoke is detected in the forward or aft equipment cooling system, accompanied by an ICAS advisory message. Both supply fans and the recirc fan in the affected system will turn off automatically to prevent smoke from entering the air conditioning system. The overboard exhaust valve opens automatically, allowing differential pressure to draw the smoke from the system. After the smoke is cleared, the recirc fans automatically return to the normal operation. Now let's look at the 767 differences for the equipment cooling system. The 767 has 3-position equipment cooling selectors. The auto position allows the system to operate automatically and provides the most efficient mode of cooling. The equipment cooling overheat light will illuminate if the electronic equipment is not adequately cooled, accompanied by the associated ICAS advisory message. Additional equipment cooling can be obtained by selecting the standby position. Now click on the equipment cooling selector to select the standby position. This should cause the overheat light to extinguish. If the overheat light does not extinguish, or if smoke is detected in the cooling system, select the override position. Now click on the selector to select the override position. Override operation changes the source of cooling to the pressurization system. With the overboard exhaust valve open, differential pressure causes the conditioned air to flow across the electrical equipment before being exhausted overboard. The smoke light will extinguish when the smoke has cleared from the system. Keep in mind, however, that the equipment cooling air will not exhaust if the airplane is unpressurized or if the exhaust valve fails to open. The no cooling light illuminates if the selector is in the override position and no cooling airflow is detected. If an overheat condition occurs on the ground, the ground crew call horn will sound. In addition, the no cooling light will illuminate. Selecting override will not provide additional cooling because there is no differential pressure to draw the cool air across the equipment. Now let's look at cargo heat. The cargo heating system is completely automatic. There are no cockpit controls or indicators except for ICAS status and maintenance messages. Now let's look at the 767 differences for cargo heat. All 3 cargo bins on the 767 airplanes are heated. Heat for these compartments is provided by cabin exhaust air and bleed air. The cabin exhaust air is ducted along the outside compartment walls and then discharged overboard through the pressurization outflow valve. Bleed air is ducted under the cargo compartment floor for additional heating. Cargo heating controls and indicators are located on the overhead panel. There are separate switches and overheat lights for each cargo compartment. When a cargo heat switch is selected off, the respective shutoff valve will close. Now click on the appropriate switch to apply heat to the forward cargo compartment. When switched on, the cargo heat valve operates automatically to maintain the cargo compartment temperature above 45 degrees. There is also a bulk cargo compartment heat selector located on the accessory panel. In the normal position, the temperature in the bulk cargo compartment is maintained above 45 degrees Fahrenheit. With the selector in the vent position, the compartment temperature is increased to a minimum of 65 degrees Fahrenheit. The vent position also switches on a ventilating fan. This fan circulates cabin discharge air through the compartment and exhausts it near the outflow valve. In the event of an overheat condition, the heat control valve automatically closes, shutting off the supply of bleed air. If the temperature in any of the 3 cargo compartments exceeds 90 degrees Fahrenheit and the heat control valve fails to close, the cargo compartment overheat light illuminates, accompanied by the associated ICAS advisory message. When the overheat light illuminates, The shutoff valve will close until the temperature drops below 90 degrees Fahrenheit. When the compartment temperature drops below 90 degrees Fahrenheit, the overheat light extinguishes and the advisory ICAS message is canceled. The shutoff valve then modulates to maintain a temperature between 80 and 90 degrees Fahrenheit. The decision to allow cargo heat to cycle at 90 degrees may be based on the type of cargo in the compartment.